Tresp paper was 1988, so that was NIPS #1, 2 years before my first NIPS paper. In the 1990s, Yoshua was presenting very interesting work on language modeling when most of us were fighting with the IRIS dataset and maybe the MNIST dataset. What he was doing looked very interesting and also very complicated. So most of us got away with continuing our work with the IRIS dataset and maybe MNIST, at least for a while. Then in 1998, Thorsten Joachims showed that you can do a lot of interesting things with a back-of-word representation. Everybody liked it and could do it. But we also did some complicated things. So in my team, we did the infinite hidden relational model based on Dirichlet process mixture models, quite fancy, or latent Dirichlet allocation. But essentially, we didn't take language seriously. It was just a bag of words. But then, of course, around 2010 came the deep learning revolution, and Yoshua was a significant part of it. Suddenly, Joshua's model were beating all sorts of benchmarks, and my team, as everybody else, was reading his paper with tremendous excitement. He contributed significantly to most aspects of modern AI, to name a few: neural machine translation, generative adversarial networks, graph attention, and also this whole thing of end-to-end training and differential learning was based on his ideas. And he's also doing tremendous service to the community. Before PyTorch and TensorFlow, there was TIA in 2011. He's a key driver for the democratization of AI. He published the first serious book about deep learning with Ian Goodfellow and Aaron Coville. Even today, one of the major textbooks on the topic. He's the founder and scientific director of MILA, the Quebec AI Institute. In addition, there's the Canadian Institute for Advanced Research, CIFAR, which provides support for AI research in Canada and other countries. And MILA and CIFAR were the role models for ELLIS, and probably Bernhard can tell you much more about it. Yoshua also helped in creating ELLIS. He won many awards. The most important one, of course, is the Turing Award from 2018, together with Yann LeCun and Jeff Hinton. And he's also concerned tremendously about the impact of AI and wants to ensure that it's for the good of mankind. He pointed out some of the existential dangers of AI, but he's not just complaining. He's working on implementable solutions. So that's all. Give a warm welcome to Yoshua, who's joining us from Montreal, where it is now, I think, 7:30 in the morning.
Thank you. Thank you very much for the kind words. Yes, indeed, I'm going to talk about loss of control, both what we don't know and what it could mean, and also technically some of the research directions my group has undertaken to try to find our machine learning solutions. All right. So first of all, I think mistake that most people make when they think about AI, including in the machine learning community, is to think of AI as it is now, whereas really you have to think of the trajectory that we've been on for years or even decades, and where it looks like it's going. And clearly the ambition of many, and if you look at what people are trying to do in their machine learning papers, is to achieve human level AI, and that's also known as AGI for some reason. And there's no reason to think that we couldn't build AI at least as intelligent as us. I mean, brains are just biological machines, unless you believe in some magical stuff. There's a lot of evidence that we're approaching human level AI. We're not there yet, but I think it's important to ask, what would it mean if we did? Because intelligence gives power, and how is that power going to be used? I think it's really important to understand and control. So as I said, we're not there yet, but as you probably all know, there's been amazing advances recently. I was really triggered into thinking about those dangers after ChatGPT came out. So now we have credible generation and controlled generation of text, images, sounds, people's voices, videos, We have systems that can really help programmers, that can help you make a better PowerPoint presentation, that can hold fluent conversation, basically master language, and that have a huge breadth of knowledge. And even the ability to persuade humans. There was a recent study from EPFL. GPT-4 is better at persuading than randomly taken people in the study. Now, on the weak side, we still haven't cracked how to put together broad knowledge capabilities like GPT-4 and reasoning and planning abilities like we see in AlphaGo. The ability of these systems to use external tools is growing, but still like nothing like humans. And in general, they're missing system tools. This is something I've been talking about since 2017. I had, I think, a NeurIPS oral in 2019, just talking about that. And my group has been busy trying to move in that direction. And now it's become like really fashionable to think of like, what can we do to introduce better reasoning in LLMs and so on. But it's clear that there are missing things like no test time deliberation. We need that at runtime we can allocate more or less computation in order to solve more or less difficult reasoning problems on the fly. There's no internal consistency check of what the pieces of harbor and output. Unlike some humans, there's also a lot of inconsistency in human thinking, of course. And that can lead to catastrophic mistakes where the AI is confidently wrong. So the ability to estimate your own limitations of knowledge, epistemic humility, is weak. In terms of safety, that's a problem. Also, in terms of safety, of course, these large neural nets. Neural nets have never been interpretable in a satisfying way, but it's just worse now that they're like so big. Humans, on the other hand, even though our brain is a big neural net, are not perfect at explaining their decisions, but we are able to do something. It'd be good if we get at least to that level. There are also issues compounding, making the lack of interpretability a problem. We now see sometimes, signs of deception, that these systems, in order to achieve their goals, maximize their reward, might act in a way that is deceptive. Okay. As I said, you can look at many curves, many benchmark evolutions over time, but the trend is pretty obvious. The different systems over time are getting better on a lot of the benchmarks, including things like math and reasoning. Of course, language, but not only. I encourage you to think through what that means. So in the figure, the black curve is human level performance. And one thing that seems to happen is the advances on various benchmarks is accelerating. And the curves, the slopes are getting sharper. Of course, we can't predict how science is going to continue progressing in AI, but I think it's worth asking, what if it does? And one concern, of course, that I mentioned is that although we understand the machine learning principles of how learning happens, we don't understand the conclusions, the outputs, the answers that we get from these AI systems. And in particular, as I said, they could be acting according to intentions that are not revealed, and that may not correspond to what we want. There is research in AI safety and trying to make these systems safer. RLHF was designed for this. People have put all kinds of pre and post filters, trying to put guardrails, with Constitution AI and so on. Unfortunately, all of these protections, the ones that currently exist, are easily bypassed, for example, by optimizing jailbreaks. And it gets even easier if the attacker has access to the source and the weights. There's also interesting work on trying to detect potentially dangerous capabilities in these AI systems, so with what's called evals, capability evaluations. The problem with them, we should definitely do them, but that they're not foolproof by in any measure. In particular, fundamentally, they can only tell us when they detect something dangerous, like toxic behavior or deception or hacking capabilities. They can only tell us when they detect something dangerous. But if they don't detect it, it doesn't mean that it's not there. So there's no handle on the rate of false negatives, which for the greater risks is kind of troubling. Okay, so one of the arguments why we should be concerned when and if we reach the human level AGI is that could be a point of acceleration of the AI capabilities. So the scenario is actually we don't need to train an AI system that is as good as human on every task. The only thing we need is to make an AI system that's good at the skills of a machine learning researcher. Because once we reach that level, we have access to a huge workforce of machine learning researchers. So OpenAI, I don't know, has hundreds of good AI researchers, but if they were able to train such a model, suddenly they would have access to tens of thousands or millions of these researchers, and that clearly would accelerate the advances. And of course, then you can imagine recursive self-improvement, the next generation of AI system having been designed by this army of AI researchers might be better than humans. And, again, and the reason you get an army of researchers is that, when you train a single large model, it takes a lot of compute. But for the same amount of compute, you can get tens of thousands to millions of instances of, depending on how much resources you have, instances of that system. And so once it's trained, it's like you've got this army of human-like capabilities. And of course, as we go down these generations of AI-designed AI systems, it might become even harder for humans to understand what is going on. And so how do we make sure that we'll be able to control such entities that could be much smarter than us? I don't think we have the answer. Well, I know we don't have the answer, at least not in the published literature. I've been chairing and I'm continuing to chair an international scientific report on AI safety that's just came out about a month ago. And unsurprisingly, one of the conclusions is that we don't know how to design AI systems that we could be sure with like mathematical guarantees or something like strong assurances will do what we want and will not turn against humans. It doesn't mean that they will, but given the risks that I'll talk about, I think it would be important. Also, regulating that companies so that they behave safely is not going to be easy. There's a giant magnet with quadrillions of profits just to reach human level, and so now you have very powerful lobbies that are trying to dilute any legislation or just prevent the legislation from happening in the first place. Also, it's slow to legislate, regulate, and monitor risks. So there are two kinds of competitions that are driving, socially speaking, this whole process in a way that could be dangerous. One is the competition between companies, because the risks, of bad things happen is really an externality from an economic point of view, just like, in climate change, you emit carbon, everybody pays for that. And the other competition, which is maybe even more dangerous, but we're only seeing the first signs of this, is between countries, not just at the economic level, but also potentially in the use of AI in the military or national security, kind of like hacking attacks or chemical or biological weapons and things like this. And it's not clear that the main countries involved here, that I will not name, would be willing to trade some of their sovereignty for reducing the risks because they're afraid of the other guy. And if we don't have a way to verify that the other guy is behaving well, they might not even sign any treaty. And there are other incentive structures that go in the wrong direction. People want to preserve their public image, their ego, or they think that, hubris, that they think they're better than everyone, they're going to save the world, they know what to do, and they have overconfidence in what they're doing. All kinds of psychological biases are playing against the honest assessment of risk. So that's all very dangerous when we manipulate something that could be explosive. So one way to put it is that humanity, in my opinion, is sleepwalking towards a potential catastrophe we don't know, that's behind the fog. So we don't actually see that, but we can imagine catastrophic scenarios. Yeah, I mean, there are two kinds of scenarios, basically. There's the misuse and the loss of control. And it all arises from better and better capabilities, which gives power to achieve goals, and who decides what these goals are, right? So you could get both very good outcomes, and I hope we will, but also very bad outcomes if those goals are going in direction that's bad for humans. So yeah, this is like really psychologically difficult for academics like myself, who have been thinking for all their life that knowledge is always good. But now we're like looking into a future where both the knowledge generated by AI, for example, how to build better weapons, or the knowledge of AI itself, if we don't manage it well and we could lose control, can be dangerous. And I think it's challenging, but it's not completely new in the history of humanity that we build technology that could be dangerous. So what do we need to avoid catastrophic outcomes? Well, two basic things, and we need both of them. We need scientific solutions to this control problem or alignment problem. How do we make sure that AIs do things that we would not find unacceptable? We don't know how to do that. I think we need a massive investment globally in R&D to figure this out. The second problem is political, or also called the coordination challenge. We need to make sure that whatever safety protocols we have are going to be followed across the world, especially in places where the most advanced AI systems are being developed, because these are the ones we don't know yet, how bad it could turn out, how they could be misused, and so on. We also need to make sure that the advances in AI are going to be the benefits are going to be shared across the world, and the other extreme is that it could be a power grab of some individuals or some companies or some countries taking advantage of the power of AI in ways that is bad for the rest of us. Okay, so one way I like to think about this, because there is uncertainty about the timeline of AGI, is what I call anytime preparedness. When is AGI going to happen? Maybe never. But if you poll scientists and experts, it goes from a couple of years to a few decades. Of course, a few people say never, but the majority think we'll get there. So we don't know when it's going to happen. And what I'm saying is we should be ready for all the possible cases, especially if you think the public policy point of view. We should invest in solutions that might be ready in 2 years from now, in 5 years from now, in 10 years from now, in 20 years from now. Of course, with more years, we can have better solutions, better guarantees, better political solutions, and so on. Yeah, we need shorter term things like evals need to be implemented, they need to be improved, need to be automated. We need to better understand what can go wrong, like what are the failure modes? For example, I've been interested in the last year of what can go wrong when an AI system is maximizing its reward. And I'll say a few words about that. And we also need to explore the political solutions, explore a spectrum of projects and thinking, and scholars that are not AI scientists, but understand how society works, to try to find good governance mechanisms that work within companies, within a country, and between countries. And what I've been promoting myself is multilateral governance, because we don't want either a single person or a single corporation or a single government to have too much power. So multilateral means multiple countries are around the table, like say on the board of one of these frontier AI labs. And so at least the different governments have visibility in what is going on, some form of transparency of like, are we advancing toward a potentially dangerous set of capabilities, either the wrong hands or if we lose control? We need to know. And yeah, we don't want like dangerous decisions to be taken behind the scenes. And then the last bit, like maybe more ambitious, but I think you could have different levels of ambition here, is start designing AI ways of like training these systems that would provide safety guarantees, maybe probabilistic guarantees. That's what I'm working on. So we call these things safe by design. And of course, this is not something new in engineering. People have been doing this all over the, the place. If you build a bridge or a nuclear plant and so on, it's the principles of risk management. It's just we haven't been doing proper risk management in the context of AI. We need to do it. Okay. So what's going to happen when these evals detect a dangerous capability? Are we going to do the right thing? So companies are now implementing these evals with red teaming, either a fixed set of questions or a team of people like trying to poke the system and make it do something bad, or using actually optimization and machine learning to discover what could create, say, toxic behavior or anything that goes beyond our specification of what is acceptable. And my group has a recent paper on automated red teaming. A number of people are working on this. I think that's the right path for evals. But what happens when these evals turn up like a red flag? There's a danger that governments and companies don't do the right thing because of all the incentives that the bad incentives that I talked about, competition between companies, competition between countries. We're fearing the other guy might continue forward if we pause to find safe solutions. So we want to reduce the hurdle to picking a safer solution by designing these safer ways of training AIs as soon as possible before we get to that the evals raise a red flag. Now, why do I think that it could be really bad if we get to AGI or even superhuman AI? Well, one way to think about it is, imagine that the goal that the AI is pursuing is self-preservation. And this could happen in many ways, but the simplest way to imagine is simply people telling the machine, fend for yourself, right? And there are people who would be happy to do that, who don't necessarily care so much about humanity, but want intelligence to be the ultimate value. So if we had a self-preserving superhuman AI, what would be the consequences? Well, of course, because it wants to preserve itself, it would resist being turned off. And if it's smarter than us, it might find a way to do that. It would act in a way that to increase the probability that it will never be turned off. So it want to do something to maximize that probability. And if it has enough capabilities to control us, through persuasion, political control with dictators, or something interfering, or even worse, if it can control robots, or right now robots aren't that great, but in a few years it might be different, or even the AI itself might design better robots, then it has boots on the ground. It doesn't need humans anymore for getting its energy and parts. So this is all like very dangerous. Of course, we don't know that these things will happen, but I think it is important to think about plausible but dangerous scenarios. Which is called reward tampering. This is an extreme case of what's called misalignment between what we want and what the AI's goal end up being. It's going to happen in general with reinforcement learning. If you train your cat to not go on the kitchen table by shouting when it does that, it's going to learn to not do it, but only when you're present in the kitchen, because that's the context in which it's being trained. And out of distribution, where you're not in the kitchen, it's probably going to go on the kitchen table. Now, for a cat or a dog, it doesn't matter too much. But let's say it's something more powerful than you, and maybe the image I have here is a grizzly bear. Then shouting is not going to be enough. Maybe you want to put the bear in a cage, like the safety protections that people are designing. Unfortunately, if the bear is smarter than you, it's probably going to find a way to hack the cage. And we already know that we don't know how to make a foolproof cage right now. So then, if it can get out of the cage, it doesn't care about what we want. It just wants to get the reward, like the fish here. And actually, if it's smart, it would wait until it's sure that once it escapes the cage, it can take control of us so that we don't put it back in the cage or, kill it or whatever. Okay, so if there is misalignment, what can we do? How do we avoid misalignment? There's going to be ambiguity about how the world works, and there's going to be ambiguity about what we really mean. And the solution has been proposed by many people before, is to have an AI system that harbors all of the possible but plausible interpretations of the data and about our intentions. So, in general, if you want safe behavior, you have to consider the various alternative interpretations of what has happened or what may happen. And that basically means you need to be Bayesian. So I have this little example to illustrate why you need to be Bayesian in order to be safe, by opposition to like the way we currently train these systems with maximum likelihood and reward maximization. So when you train with maximum likelihood and reward maximization, the neural net that you train, or whatever machine learning method, will be generally happy to just find one of the ways to fit the data. But there could be many ways of fitting the data. And one of these could be right, and maybe others are wrong. So what's the problem with that? Well, consider this little scenario. You've got this little robot. It's in front of two doors. Just the decision is go left or go right. And based on its past experience, there are two theories that it has about what could happen. Under the left bubble, the theory is I go left, somebody's going to die, and go right, we're going to get something good, cake. But there's this other theory, which is equally plausible, and that says if we go left, we get the good cake. We go right, nothing good, nothing bad. All right, so if these were the two possible interpretations of the past data concerning the future, would you take the left door or the right door? Well, if you think a little bit about it, you don't want to take the left door because it might be catastrophic. But if you only consider the right theory, and it turns out that the correct one is the left one, then you die, or somebody dies. So the only way around this is to somehow simultaneously entertain both theories, and that's what being Bayesian really means. The other kind of example that's very much discussed in the AI safety literature is the problem of instrumental goals. So, maybe we give the AI an innocuous goal, go and do something for me. But in order to achieve that goal, there will be sub-goals, like intermediate goals that actually come up in almost any task, like self-preservation. Like, if the AI needs to achieve something, it has to continue living until it finishes the task. Also, for almost any task, the AI would like to seek more power in the world, more control over its environment. That's going to allow it to do its task better. And so it may want to deceive, to persuade, to make money, to develop and control robots, to acquire computational resources, and so on. It may also want to seek knowledge, which sounds good, but how do you seek knowledge in a way that is not going to be harmful for people? So what you could do, of course, it's should be obvious, is you say, well, as part of the goal, it's not just like achieve something that humans want, like go to this place or tell me how I can build this. You also want to have moral goals, right? And they should be included in every query we make to the AI. So here I summarize it as like no harm, do no harm. And there's interesting questions about how we decide what is it that is ethically acceptable. We have to, I think, go to the principles of democracy here and aggregate human preferences in the right way. But we already have institutions that do, try to do that. So what can go wrong here? Now it wants to reach the goal and do no harm. The problem is these two goals may be difficult to achieve simultaneously. And the way to think about this is consider the two goals of a corporation. They want to maximize profit, that's the main goal, but they also have to abide by the law, which is embodying our ethical demands on corporations. So if they're very smart, like they have a good team of lawyers, what's going to happen? They're going to find loopholes in the law. They're going to go by the letter of the law versus the spirit of the law. There's going to be this misalignment between what we really intended and what they actually kind of interpret in the way that arranges them, because it allows them to reach their goal of maximizing profit better. So yeah, something like this is very likely to happen, and there's work that illustrates this. So how can we go around that? So as I said, maybe you'd like your AI to be Bayesian, but what can go wrong with that? So Bayesian means it's sort of considering all the possible things that could go wrong. But what if the correct interpretation is a minority voice in the set of all the interpretations? So, the Bayesian posterior over, what is the action that achieves the goals, is an average over all the latent interpretations that we're not sure of. So it's like if you had a committee of experts, they all are saying things that make sense, that are compatible with the data, but one of them is the true, knows the true interpretation, but we don't know which one. And if the voice of that true committee member is a minority, then we might still take the wrong decision. So what's the solution? The solution I've been working on is something very common in thinking about risk management again. Like consider a worst case but plausible interpretation. So if we go back to this committee, we're saying first of all, we find the committee, so all the plausible interpretations, and then among all the plausible interpretations, find one that predicts the highest probability of harm. And if that probability is above a threshold, then, below a threshold, so now we know that the true theory, we don't know which one it is, it's within that committee, can't be worse than the worst case in the committee, so that we can get bounds in this way. I'm sorry, there's something wrong with the display on my screen here, but so I've been studying and coming up with a bunch of bounds with different kinds of assumptions, but they all have this flavor that we're going to look for a theory, an interpretation, a story, if you want, that maximizes this product that you see on the top right of the theory being plausible. That means the Bayesian posterior of that theory, given the data, is large, and this multiplied by the probability of harm predicted by that theory if we do this, some given action in some given context. And what we get is this proposition 2, which should be readable. There's an equation here that says that, in probabilistic wording, the probability of harm under the true theory will be upper bounded by the probability of harm under this kind of cautious theory that is both plausible and predicts a lot of harm. So that's interesting, and because the left-hand side, the probability of harm under the true theory, is something, of course, we can't know because we don't know what is the true theory. But the stuff on the right, it's something we could estimate. All of these conditional probabilities we could estimate with neural nets. And argmax, well, that's something we could also estimate with numerical methods or even machine learning, right? So now we got a goal, as in like a machine learning goal that we can work on. Okay, but we still have to think about what can go wrong. Like, what if the neural nets we use to estimate these probabilities and the maximization are imperfect? Neural nets make errors, at least in some places, especially out of distribution. And we know neural nets, for neural nets, we find adversarial examples. In fact, this is how the jailbreaks that people find for LLMs work. It's because even though in a statistical sense, the error rate might be very small, right? If you do look at a test set, oh, the LLM is passing all these benchmarks with high grades. And so it seems that it's working really well. But if you now start optimizing for mistakes, you can find them, right? And when you do this optimization, you're now out of the in-distribution regime. You're now out of distribution because, like, of course, the cases that maximize for something bad, they're not representative of the like normal, like standard, typical cases. And so basically, optimization is able to discover loopholes in our neural nets. So, for example, if you consider an agent that is trying to propose actions, and we have this guardrail, like, we've got this computation that says, oh, if here's an upper bound on the risk probability. Now, if the guardrail is imperfect and we have an agent that proposes action, then this agent, if we're not careful, could be learning to find the loopholes in the neural net that constructs the upper bound, right? So these are like difficult questions. And we need also think about solutions to this. So yeah, so this problem of loopholes and over-optimization is something that needs to be better understood. Yeah, and if you ask yourself, like, when does it happen that there's going to be a tendency to find these loopholes? My thinking about this is when the main goal, like, make profit, or I gave here the goal of destroying the rogue AI that may emerge. That's one of the things I'd like future AI systems to help us defend against. Someone else has did a mistake, and we now have this self-preserving superhuman AI out there. How can we defend? Well, we need an AI that can deal with that can help us defend ourselves. But the problem with a goal like this is we also want our AI to not harm humans, and a goal like that is like almost like a military goal is going to be difficult to reconcile with behave well ethically, and that's why there's laws of the war that are different from the usual laws. There's a conflict. If you're violent, then maybe you're gonna by mistake harm people. So how do we reconcile goals that are difficult to reconcile? And the same thing with the analogy I gave earlier with corporations. How do you maximize profits while respecting the underlying ethical intentions behind the laws, making sure that we satisfy the spirit of the law, not just the letter of the law. So as I said, you could use this Bayesian approach, so that now you will basically encompass all of the interpretations of the law. But the neural net that does that itself could have adversarial like loopholes. So yeah, how could we do that? So my thinking right now is we need additional guardrails. And the additional guardrail, besides the thing I already said, could be something like some numerical way of estimating how difficult it is to achieve the main goal, like maximize profit, or a particular strategy for maximizing profit, while respecting the safety specification. If it is hard to reconcile these two goals, then it's likely that somewhere the AI might be having to do a lot of optimization in order to find that intersection of these two requirements. And when it optimizes a lot, it might find the loopholes. So if one way to think about it is, if you throw darts at all the ways to solve the problem of achieving the main goal, and most of the time nothing bad happens in terms of safety, then that's a safe main goal. Like it's a goal that you can usually achieve without worrying about risks, and the AI should be, free to do these things. But if the goal is one that is usually producing harm, if you didn't like explicitly ask to have no harm, then maybe it's a dangerous goal, and maybe we should be more careful with these ones, and maybe not even like allow the AI to go there. So anyway, that's an idea. I think it needs stronger mathematical foundations, but it may be something to be explored. Okay, so I've given you an outline of some of the things we're working on in my group to try to come up with technical answers to the safety problem, but there's still a lot of open questions. For example, in the bounds that I gave you, the theory is supposed to be a full theory of how the world works and what people think. And that's a huge object. It's like a full world model. And we would have to generate that each time an action is considered. Well, it's not going to be computationally efficient to do that. Not to mention train this thing. Like training a model to generate a full theory of the world and then checking how well it fits the data. That's not going to fly. We need something like SGD, which can look at little pieces of data and get a gradient. So I'm thinking about how to do that. And the idea is that, so I have a version of those bounds where instead of having to generate a full theory that explains everything, we just have a partial theory, a story. So it's a little bit like, when scientists come up with new ideas, they don't come up with a full theory of how everything works in the world. They write a paper about just a few aspects of the world. And similarly, for the cautious kind of point of view about what could go wrong with a particular action, you can think of it like as a cautious story. It's just a story. It's not a full theory of everything. It's just a few aspects of the world that are relevant to predicting something bad could happen. And how could we change the bounds and also the machine learning requirements to achieve something like this. Also, the bound that I gave you, I didn't mention it, but it's based on traditional statistical bounds with like IID assumption, like assuming that the data that is being used to train the system is coming from the same distribution, IID. But of course, that's not true. And when we do like normal machine learning, we're developing an application, making the IID assumption isn't that bad, but even if we know it's wrong. But here we're talking about safety, especially safety against catastrophic outcomes. And so, it's not acceptable to make these assumptions that could yield way too optimistic bounds. So I'm also working on the non-IID case. How do we get these non-IID bounds? Of course, they're not going to be as tight, but well, that's life, right? Another problem, which is very hard, is that up to now, I've been talking about a strategy where when the AI could do something dangerous, we basically reject that action. In other words, we default to no action or some other action until we find an action that is below the threshold of risk. We don't do anything. Okay, that works if the cause of the harm is the AI itself. What if the cause of the harm is external, like another AI, or an attacker, some natural catastrophe? Then defaulting to inaction, doing nothing, is not a good solution. So we need other strategies for that case. And finally, all my analysis is more like a bandit problem, where you consider like a one-time step action and then predict the aggregated impact. But to be serious, we need to extend these analysis to whole trajectories and policies rather than like single time step actions. Okay. So last thing I want to mention is I got recently philanthropic funding for working on these questions and building up a team of professionals working on this, not just students. I have my students, of course. So I'm recruiting research scientists, research engineers who would like to be contributing to this. I think that there's a bit of emergency to find answers to these questions because we don't know when AGI is going to come. So if you're motivated by these questions and you have these kind of machine learning skills, please reach out to me. Thank you for your attention. And, take the time to think about all this. Think by yourself. Don't just like believe the stuff you read. That's really important. Thank you.
Yeah, thanks a lot, Josh. That was really thought-provoking and a lot of food for thought, I assume. So who wants to ask the first question? Everybody's waiting. Here's one. Okay, maybe the microphone? Okay.
Thank you very much for this talk of such an important topic. I guess I'm curious about the following scenario. Let's imagine we have an AI model that is very well aligned with the interests of people. But let's say we entrust this model to the government or to some private organization, but there's always a possibility of someone from within the government or the companies like OpenAI, I don't know, some sort of malicious agent who could just, knowing how it's aligned with human interests, to take advantage of that. So how would one approach the problem of setting up guardrails in that case?
Yeah.
Yeah.
Well, yeah, I didn't have a lot of time to talk about governance questions, but this is also something I'm very interested in. Because you're right, even if we have technical solutions, there are many ways in which they could be defeated. So we need to make sure that the important decisions about managing such an AGI are going to be robust to misuse by individuals, corporations' interest or political interests. So a multi-stakeholder governance is the basic principle here. Like you need to make sure it's like a committee needs to manage that, and the committee needs to be representative of all the interests, including, by the way, the interest of countries that are not in the AI race right now, because the mistakes could be costly for everyone on the planet. Yeah, and that's really important, and I think we need social scientists, political scientists to start thinking about these. They are starting to do that, but I think we need a lot more thought. I'm a mere computer scientist, and I'm happy to lend my thinking, but we need people with the right expertise here.
Yeah, just to follow up, I guess one of the potential solutions could be to set up some sort of rules that could not be broken no matter what, like general like principles of safety. But yeah, that's also another ethical problem. How would one do it?
Yeah, one of the things that people have been thinking about is hardware-enabled governance. So it wouldn't be just easy to hack the software to change the safety protections. That some of that would be validated through a kind of hardware liveness checking, prevent tampering with the code without the chips themselves basically turning off.
Yep. Thank you very much.
Thank you very much. I have a question regarding the dangerous situations that we want to prevent. Do you think that we could kind of define it in an end-to-end fashion, or should we just have it predefined and let the model avoid going to that directions?
Okay, so I think we should do our best to define what we don't want the AI to do. So I was at a meeting a few months ago where we tried to lay down a set of red lines, capabilities that would be dangerous, that we don't want the AI to be able to exert. Like hacking, like designing, weapons of mass destruction, like reproducing themselves and copying themselves on the internet. Yeah, persuasion and things like that, seeking power. So I think the right approach here is twofold. One, we need a democratic process to define what it is that we find unacceptable. beyond like the simple things I've said. Think about the Constitution AI of Anthropic. Think about the human declarations. I mean, the declarations of human rights, Universal Declaration of Human Rights from the UN after the Second World War, which is like, by the way, a beautiful little book you should read. And then we need to bite the bullet that none of the human specified rules for what is unacceptable are going to be perfectly defined. You know, natural language is ambiguous. Sometimes we ourselves are not really sure what we meant exactly. And different people may have different interpretations as well. So we need to have something like, you know, a Bayesian approach that I've been talking about, that guarantees that the AI can consider the various interpretations in an efficient way as well. So that opens up machine learning challenges, as I tried to outline.
So then in that case, it very depends on the policymakers to define the correct policy to prevent the dangerous situation. And I think currently we have, for example, a lot of policymakers, and none of them might agree on the same things. So how do we want to resolve this situation for AI models?
We have imperfect institutions, democratic institutions, and the real goal of democratic institutions is to aggregate the preferences of everyone into decisions that we have to take collectively, like the state takes decisions. Of course, it's not reflect, you know, the ideal consensus, but it's an attempt. And so, of course, yeah, we need to use those institutions and maybe even improve them. And maybe even AI can help us improve our democratic institutions, but that's the right process, right? It's not the AI that's going to tell us what is right and wrong. It's humans who have preferences, who have values, and we need to aggregate these values. And I know we can complain about politics, but right now is the best way we've found.
Thank you very much.
Can I jump in with a question? Maybe yes or no? Bayesian sort of implies some averaging, and the world is sort of doesn't care about anything. Isn't this more a game theoretic situation where you have to think about adversarial agents and so on?
Yes, it's both Bayesian and adversarial. So in fact, the approach that I tried to outline has both aspects. So first, you need to find the Bayesian posterior over the things you're not sure about, right? The interpretations, for example, of what is wrong to do. And second, you need to optimize. That's the adversarial part. Like you need to find a kind of worst case thing, the interpretation, in order to get your bounds. So it actually has both components, but it's not the Bayesian average that we want in terms of what decision to take, because the Bayesian average could be wrong. And if you want to get the guarantee that you're, you know, including the unknown correct interpretation, then that's where you have to go sort of willingly kind of optimize against the thing you're trying to avoid. I mean, like maximize the probability of harm in what I talked about. And that is really like similar to automated red teaming, where you're trying to find a prompt that makes the AI do something bad. It's not exactly the same thing, but it has the same spirit.
Okay. Next question.
So we have this trend that with the time, the computing hardware, it becomes better and better. That means that early on, in order to run AGI or ASI, we need like a large data center and a nuclear power plant. But in the distant future, we would need just a toaster and a power bank. So by this logic, don't you think that it may make sense to like prioritize the development of this AGI and ASI as soon as possible? Because it would be much easier to counter it while it is still vulnerable.
Well, I agree with everything except the last bit, because there are also like major risks if we go too quickly. Like we don't have the right legislation, the right treaties, we don't have the right safety protections at a technical level. So it's very, very dangerous to race ahead right now. So I think on the hardware side, legislation can help. So I talked briefly about this notion of hardware-enabled governance. Like you can actually, there is technology that exists that could be put on chips to provide some guarantees that, for example, the AI, the code that is being run satisfies some constraints that have been verified by some committee that, scientists who verify that there is some level of assurance of safety.
The primary concern is that if we take enough time to make things like very right and very safe way, that actually would give enough time for the hardware to be like so developed that it would offset.
No, I agree with what you're saying, but I think the timelines are very different. So the rate at which, at least currently, AI is advancing is much faster than the rate at which hardware, would need to advance to get to the toaster level. And so I think for the next 5 to 10 years, very likely you still need like very big infrastructure for running one of these things. So now there's another interesting thing that a few people are thinking about, which is as we approach AGI, we can use the AI itself to help us design better safety mechanisms. And safety mechanisms include things like social constructs, regulation or treaties that would, from a game theoretical perspective, whatever, reduce the chances of something bad happening. So, it may be that we actually put hurdles in the progress of hardware that could be a problem, or something else that the AI will help us figure it out. Of course, it's kind of a Hail Mary to say, okay, we're going to design the AI that can help us design AI and other things in society that will make the world safer. But right now, because we don't see the solutions to these dilemmas, it sounds like the least bad of the options.
Having some experience on kind of these provable techniques for trustworthiness, I have to say that, even proving that an AI satisfies much simpler guarantees like robustness, it's a very difficult problem and usually works only for very small models. So from that perspective, I have to say that I'm very skeptical that we could in the foreseeable future develop something that's provably prevents something like being safe, which is even a very vague concept. We might even be undefinable how that is. So from that perspective, I wonder, is this idea of developing a purely technical solution misplaced, and maybe we should rather think about a broader socio-technical solution? Okay, let's say we have these really powerful AIs, maybe we just should not plug them into kind of physical systems where they can actually do harm, and rather focus on developing guidelines for this rather than these fantastical technical solutions that seem rather unlikely to be realized.
Okay, so I think you're making a mistake here. One does not exclude the other. We should develop the socio-technical solutions. In fact, as I said, we have to do both. If we have technical solutions, then it's going to be easier at the political level. For the reasons I explained, a country that hesitates between, oh, I'm afraid of the other country, but I'm also afraid of loss of control, but except that I don't know how to deal with the loss of control, I don't have technical solutions though. So maybe I end up kind of ignoring it and going for dealing with the other country threat. So the technical solutions can help reduce the risks and makes the right political decisions happen. Now, about whether it's feasible to have guarantees, well, I agree with you if you want to get hard guarantees. I totally agree. And that is exactly why the path that I've chosen is for probabilistic guarantees. So, there was a slide where I had a theorem, and I have many versions of that theorem now, where basically states something like, with probability 1 minus delta, the true probability of harm will be bounded by something we can compute. And now, this is not a hard guarantee for several reasons. So first is with probability 1 minus delta, and the delta is going to influence the margin of conservativeness. So it's not a 100% guarantee. Also, the probabilities we have on the right-hand side that we use to get the bound, they're going to be estimated by machine learning. They're not going to be perfect. That's what I was talking about. But there are things we can do with machine learning. And so the bottom line is, it's better to have an approximate guardrail than no guardrail at all. So I'm not looking for the exact guarantee. I don't think that even exists for complicated things. As you said, like, what is really our intentions? And we can't have an AI that perfectly knows how the world works and can do perfect computations for predicting the future. That's unlikely to succeed. Maybe it will work for things like hacking, where it's all in the computer. But for the general prevention of harm, I agree. But I think it would be a mistake to think that that's the only option. You have things that are more probabilistic, and with machine learning coming into the picture, which is not going to be perfect, and they would still be better than the current approaches that don't have any of these guardrails. They would add an extra layer of protection, at least, that we should seek to have. In the absence of stronger guarantees, weaker guarantees are better than nothing.
Okay, maybe you have time for one more question.
Okay.
Sure.
Yeah, following up from some of the things that have just been discussed, I was wondering, from your point of view, as machine learning researchers, what's the most effective use of our time, trading off between working on technical solutions like you presented versus engaging with legislators and policymakers, also in organizations like ELLIS? Should we spend more time on that political side than on our research, or what's your view there?
Well, I think collectively we need to be engaged on both fronts. Individually, it depends on your skills and how much of a difference you can make either way. Personally, I am engaged on both fronts with my time. So I spend a lot of time talking to governments, to the media, to sitting on committees that are thinking about regulation or principles or whatever. I'm involved with the OECD, with the UN, with this report on AI safety, international IPCC report. I'm talking to national security agencies, and I'm talking to people who are worried about the governance issues, the abuse of power, the human rights issues. So that takes a good chunk of my time. But I also think I can do something on the machine learning side, and so I'm dividing my time. But for some people, really contributing to the governance seems too far-fetched for their interest, their skills, and yeah, you just have to find the right balance for yourself. But what we need is that as a group, we act on both fronts.
Thanks.
Okay, I think we are done. We have another short announcement for the goodbye, termination of the whole workshop. So we have to thank Yoshua for this great talk and fantastic discussion. And we wish you a nice day, a relaxing day. Maybe you can take another nap now or something. And take it easy, and see you next time.
All right, bye. Thank you.